Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Solihin bin Mazlan and my supervisor is Dr. Zainoha binti Zakaria. So my presentation today is about effect of graphene oxide on mechanical, thermal and physical properties of impact modified polylactic acid. So we start with introduction of my project. Nowadays, PLA popular in most of polymer products due to its biocompatibility, sustainability, and compostable. It, it, the PLA is made of renewable raw materials with linear aliphatic thermoplastic properties. PLA starts from a monomer, which is lactic acid, and this monomer is typically a byproduct from bacterial fermentation of agricultural substrates such as corn, sugarcane, or cassava. Despite of all the advantage of despite of all the advantage of the PLA, it also have disadvantage, which limiting its applications in polymer area. And the disadvantage is its possess a brittle character and low thermal stability. For this uh, for this limiting factor, limiting limiting for this disadvantage of PLA, there has two approach that have been found by previous researcher, which is the approaches which can improve the properties of PLA is by the addition of fillers in a micro or nano size and thermoplastic blending. So first is graphene oxide. Graphene oxide is our nanofiller we have been used in this project, and graphene oxide has a properties that is extremely oxygenated, highly hydrophilic substance that can be quickly exfoliate in water to produce stable dispersion consisting mainly of single layer plates. It has a large number of functional groups that makes it hydrophilic, which is epoxy, hydroxyl, carbonylate, carboxyl on its basal planes. Advantage of graphene oxide is it can greatly improve mechanical and thermal properties of polymer, and it has been proven by previous study. And the larger area of graphene oxide raise the region of interaction with the matrix of polymer, and then due to that, it's boosting the stress transfer. So the problem statement. Uh, in previous time, many company use petroleum-based plastic due to low cost and its better properties. But the plastic has caused many disposal problems, and due to that, we come up with polylactic acid. And but polylactic acid come up with another problems, which is it has low thermal stability and possesses brittle characters, which limiting its applications. So the objective of my project is to investigate the effect of graphene oxide content on mechanical, physical, and thermal properties of impact modified PLA. And the other objective is to investigate and compare the effect of kosher rubber as a blend on our mechanical, physical, and thermal properties of PLA. And our scope of study is start with loading of kosher rubber will be used to investigate its effect on properties of neat PLA, and loading of GO, which act as filler with various percentage, so that we will know the optimum value to get the highest and the highest improvement we can get. So the mechanical properties will be conducted by using fractional test. The thermal properties will be using TGA and DSC, and our characterization will be performed using TIR. And the last physical properties will be investigated by soil burial and water absorption test. The methodology that we use, we start with the methodology that we have been used. We start with drying of PLA, CSR, and graphene oxide at 45 degrees Celsius for a days, and then we extrude all of these materials in a twin screw extruder by matte blending process, and we pelletize all the sample using pelletizer, and we mold the sample using compression mold and cut the shape based on our test that we have been conduct, and we analyze the mechanical, thermal, and physical properties, and also we characterize the sample. and the preparation of and the formulation of our sample is like in the table, and we extrude a neat PLA, and also we and the second is incorporate coarse rubber with a weight 5 weight percent 5 weight percent, and graphene oxide we vary its amount by 0.5, 1.0, 1.5, 2.0 PHR. So result for our project is whereas when we incorporate coarse rubber in our polymer, we found that our polymer have a lower flexural strength. PLA CSR have a lower flexural strength compared to neat PLA. This is because PLA CSR have been found soften under bending force, which mainly cause the property tumbling. And previous research by previous scientists found that when they using scanning electron microscopy by they want to find the microscopic observation of the PLA, and they have found that when there is a presence of CSR content, the PLA will have more localized plastic deformation, which obviously induced by the CSR. So the results when we incorporate graphene oxide with various loading show that when there is a increasing trend from 0.5 PHR to 1.5 PHR. When we ignore the 1.0 PHR, we can see the increasing trend and maximize at 1.5 PHR, and it start to reduce at 2.0 PHR. We can conclude that graphene oxide have an excellent properties of have an excellent properties, which is greater surface area, surface roughness, and polarity, which make graphene oxide form stronger intermolecular interaction with the polymer matrix. Yet, when we further increase the graphene oxide content, we can see that the flexural property is reduced. But so the explanation behind this is due to agglomeration of graphene oxide in the composites, which reduce the active reaction sites on graphene oxide. So when we see that there is an extremely reduced at 1.0 PHR, we conclude that we need to see the real reasons behind this, and we found that our sample of 1.0 PHR graphene oxide loading, we found that the sample some have void in the form of air cavities, and this void formed during our compression molding process, and its affect our results in physical strength. Ductility is a measure of material's ability to undergo significant plastic deformation before rupture or breaking. In this study, the strain indicate the polymer ductility, and our strain at maximum stress is also the strain in which the sample break, which is other name is strain at break. And we conclude that coarse rubber as impact modifier is not effective in our studies due to our test is at a low strain rate, but we strongly believe that at higher strain rate, which is impact test, we can see an improvement and effective coarse rubber role as impact modifier. So thermal analysis by thermogravimetric analysis, and from TGA results we can extract out three important information, and one of it, and we start with T10%, which is temperature at mass loss of 10%, T temperature during maximum decomposition peak of DTG, and Cha residue, which is residual amount left at 600 degrees Celsius, which is due to which correspond to carbon materials that cannot be further dissociates into smaller volatile fragments. So at higher char, we can see that PLA at 600 degrees Celsius, PLA is 100% 100% degrade, and we can see that when we incorporate caustic rubber and graphene oxide, the char residue increase, and this show that there is presence of CSR and graphene oxide. When we compare between the effect of caustic rubber in thermal analysis, we see that PLA-CSR have a low T10% and TP compared with neat PLA. This is because caustic rubber has been concluded can strongly influence in lowering the thermal stability of PLA. And when we start to incorporate graphene oxide into our composite, we found that the T10% and the TTP and the TP improve, and at 0.5 the value is high compared with the PLA without graphene oxide. And this is due to interfacial interactions existed between graphene oxide and PLA through hydrogen bonds and van der Waals forces. And their inclination still could not pass the higher value of thermal decomposition that PLA possess, the neat PLA possess. This is due to presence of caustic rubber in all of our composites, which lowering the thermal stability. At 2.0 PHR, T10% and the TP is low compared to 0.5. This might be due to agglomeration of graphene oxide. And the LC results show that at first we can get any glass transition temperature for our neat PLA due to high crystalline content of the sample. And then so we can compare between PLA and PLA-CSR by melting temperature. But the melting temperature is slightly higher than the neat PLA, indicates that caustic rubber might assist in forming more perfect crystal. 0.5 PHR is the highest for glass transition temperature, and it is due to more interaction with the matrix. And generally, blending process, which is solvent blending and matte blending, generally it is incapable of providing enough interaction. However, our PLA can be the chain of our PLA which is have a low Tg can be confined by strong hydrogen bonding to graphene containing oxygen group, which graphene oxide is included in the groups, which causing the glass temperature increase. So FTIR analysis show that most of our spectrum follow the PLA spectrum because PLA is more sensitive towards infrared rays, and we can see a little change which at OH stretching, which we can see that for PLA it has a low transmittance compared to another composites with graphene oxide, because PLA because graphene oxide has graphene oxide has hydrophilic properties, which having more hydroxyl group, and when compared to PLA, the PLA has lower amount of terminal hydroxyl group, and absence of OH stretching at PLA spectrum can be explained by the interaction between PLA and CSR. PLA and CSR in CSR they have PMMA shell, and this PMMA shell is responsible for the interaction, and the interaction that might happen between them is the dipolar interaction as shown in the figure. Physical test, and our last test is amount of PLA composites being degraded is relatively very small, and we consider that our PLA is not degraded easily, but it can be composed. It is composable, and this is due to slow rate of hydrolysis processed by PLA at low temperature, and water content and the relative scarcity of PLA degrading organisms. and PLA needs a composting environment for it to be composed to be hydrolyzed into smaller molecules. So the environment is 50 to 60 degrees Celsius in 45 to 60 days. And the physical test, another physical test is water absorption test. We can see generally the rapid increase at initial period of immersion come to steady state after a period of time. And PLA with kosher rubber is higher or have higher water uptake as compared to net PLA, and this is because kosher rubber has improved the height, cause improve in the because kosher rubber has hydrophilicity behavior, which improve the hydrophilicity of the PLA. This is from the hard shell presence in the kosher rubber, which is styrene acrylonitrile (SN), is known to be hygroscopic, which causing it behave as hydrophilic, and tendency of acrylic rubber in the core, which absorb moisture, which also known as hygroscopic material. At 30 degrees Celsius, PLCSR with graphene oxide is higher due to graphene oxide structure, which when they immerse in water, the functional groups in the graphene oxide structure open gaps, and these gaps channel for transportation and storage of water molecules. And due to that, they have graphene oxide also have hydrophilic groups that can absorb and retain water molecules by forming hydrogen bonds. And overall, the water absorption by PLA and its nanocomposite is higher when the temperature is risen. Water uptake by neat PLA blends show superior behavior than in 30 degrees Celsius due to higher solubility, and reduction of water uptake start to occur at day 13. And as we expect a further reduce of the water uptake and possibly followed by a weight loss of PLA due to hydrolytic degradation. Conclusion. Flexure properties show that our flexure properties is successfully improved by graphene oxide incorporation, and kosher rubber gave ineffective result as impact modifier in low strain rate, but might be effective in higher strain rate. Kosher rubber cause a reduced in thermal stability of PLA. However, graphene oxide presence enhance a positive impact on the composites. Physical properties needs PLA needs a much longer time to degrade unless in composting conditions. PLA's water absorption is influenced by temperature. Recommendation: the interaction between graphene oxide and PLAs, we might need compatibilizer for a better interaction, and for mechanical test, we believe that combination of tensile, flexural, and impact test should be done together for a more reliable result of mechanical properties. And last, we should use injection molding instead of compression molding, because in compression molding, error can be happen easily. And thank you, and acknowledgement. I thank you and thank my supervisor, Associate Prof. Dr. Zainoha Zakaria, and my co-supervisor, Prof. Dr. Azman Hassan, for their idea and always teach us when we in doubt. And thank you for our senior for always teach us our basics, and my laboratory mate, Hoti and Fatih Adila, which always there for me when we do the project together. And for our others laboratory assistant, family and friend, thank you for your time.